Hey, hello everyone. Today we are going to solve this daily challenge from LeetCode, unique binary search tree, part 2. So we are given an integer n and we have to return all structurally unique BSTs which has exactly n nodes of unique values from 1 to n. So we have done a similar question in one of the previous daily challenges, but here we have to build a binary search tree. So last time what we did is make trees possible with n nodes. So we just made use of all the nodes there. But this time it is a BST, and a binary search tree is a tree where the root node has a left child lesser than its value and a right child greater than its value. So we have to keep this in also into our consideration. So a BST can be made from these numbers within any range. So if we consider this part, this is also a BST for the numbers 2 and 3, and this is attached to the number 1. Now this is also a BST of 2 and 3. This is also a BST of 2 and 3, 2 and 3. Similarly, this is for 1 and 2, 1 and 2, 1 and 2. So what we have to do here is not only find all the possible trees for n nodes, we have to find all the possible structures for a given range. So say I will have all the possible trees that are all the BSTs that are possible with the number 1, then using 1 and 2, then using 2 only, then using only 3, then 2 and 3, and finally we can have 1 2 3 by making use of 1 and then the tree that we can have with 2 and 3. So this is the basic intuition. So what we can do is start by writing helper function where, as I was saying, we will generate all the possible structures for a given range. So we will have a start value and also an end value. Next, we will return a vector or possible trees for the given range. So let me name it as current. Now, suppose the start number is greater than the end number. So there is no tree possible with such case. So we will write this base case where if start is greater than end, then we will just push back a null pointer into our vector and return it. Now the other base case would be if the start value is same as the end value. So suppose we have to build a tree with the node 2. So it is only one possible tree. So we will just return a single node in the array, pushback new tree node with the value start or end, and then we will return this current vector. Now that we have covered the base cases, let's move on to build the other trees when the range is greater than 1. So we will have some left part and we will have some right part. Left part would be anything like all the nodes to the left part of the root will be lesser than the root value, and so first we will have our root value that would start from start and will go up to end. Now what will be the left part? The left part would be anything that is lesser than the root value, and since we have to find the trees between start and end, so they will the lower limit of those nodes would be the start only. So we will have lefts coming from solve start. So we will, the lower bound will be start, and anything lesser than I will be in the left portion, and similarly the rights would be solve anything greater than the root node till the end value. So this will call this function recursively, and we will have all the trees possible in the range start to I minus 1 stored in a vector and returned to lefts, and similarly rights also. And we can make use of these vectors to build all the possible binary search trees. So we'll just iterate through the lefts. So auto L now we will just keep on creating a new node every time we have a different structure, like a different combination of L and R, and we will just connect it to the temporary node we created and we'll push back it into our vector. So it will be a new tree node having the value of I. So I is the root value, then the left branch and the right branch. Now we will just push back this into our array, and finally we'll just return current. So we also needed to return this only. So the initial range would be from 1 to n. Let us run it. Now since this method gives right answer, what can be our next process? Next step is to minimize this. So since we are iterating between start and end, there is high probability that the start and the end value gets repeated. So based on the start and end value, we will have different vectors of the possible trees. So making use of the start and end value, we can use them as keys and the vectors can become their values. So we can use a map to implement dynamic programming here. So basically, the key would be a pair of int and int, and the value will be a vector of three nodes. Let's name it empty. Now we just check once whether it is already present. So is there any vector already existing having the start and end values given passed to the current function? So we will just check if mp.count start n. So if it is greater than 0, we will just return empty start comma n, right? And if it is not there, then it gets calculated and we'll just return it at the end. So this gets accepted. Let's submit it. Yeah, so this is the correct solution to the given problem, and it works completely fine. So that's all for today. See you tomorrow.